Good afternoon, everybody. I'm really excited to be here. Also because I think this is a beautiful place. And it's even nicer from here. So my name is Merijn Neeleman. I work for Ultimaker, who makes 3D printers. As Klaas-Jan already said, I used to before to work at Canon and OC. It's not that I'm addicted to printing. It's more that I like to bring high tech to people, and in Ultimaker this is a new interesting challenge for me. So what I would like to share with you today is how 3D printing can, in various stages, change and support your development processes. So about Ultimaker, there's many interesting and exciting things to say, but I'm now going to talk more about printing in general, 3D printing and additive manufacturing. And so Ultimaker makes desktop, high-end 3D printers. And I think also for the professional world, they are now really the best in the world in the segment. But there's something really exciting to say about 3D printing. And as you see here, it's doubling every year, and the expectations is that it will continue to do so in the coming years. So 3D printing is really taking off. And now I can understand that your concern is not that, but is how does my service or my product take off? And for this you have processes. And I think in the past, like 10 or for some of you maybe 20 years ago, you worked like this. You start first defining and designing before investing in development. And then you started developing and testing before investing in industrialization or productizing your service. And does it take off? And then it becomes clear that, it doesn't take off, because we've learned many years ago already, that products and services are way too complex to develop in a linear way. External market context cannot come at the end. We have to build us in. So today, of course, we all know this. We work iterative, make cycles in which we involve customer need, but also business viability and technical feasibility. But still, many of us think that after a few of these cycles, we have the final solution, which will take off. But then, this does also not take off because the user needs have changed. Recognize this? So a user is a moving target. The customer is a moving target. They are also developing their needs in this complex world of service design and product service systems. So what we do today is we swap the time to market with the release time. We go to market before we start investing in real scaling up production or productizing, to already start learning in the practice in the field with pragmatic first versions. And then production is rather a choice. We tweak and tune in the field, and maybe this grows to the product, or we start a real scaled up production, industrialization or productizing. So it's rather a choice. But now back to 3D printing and prototyping. And I like to, so this model at one back is, we all know this of course, but I think this is a good framework to map how 3D printing and prototyping and rapid prototyping can really support this now and towards the future. So in this early phase, in the beginning of development, prototyping is primarily about provoking discussions and promoting internal momentum to getting the designers together by looking at something tangible, so people don't look from different perspectives. And I like that I hear a lot of the term prototyping, which I think is a very good term for this. And in the later stage, the goal is different in the development. Prototyping is about testing your main assumptions. That can be technical, but more often it's about the assumption whether it's a true solution to our customers. And then prototyping is about enabling cycles, quick cycles, to come to a final release. But then we have production. And I think production is also interesting because with additive manufacturing we have now very interesting alternatives to the conventional, long-lasting industrialization ways to industrialize. And the search of what is the most effective way and has the biggest customer value of all the different options we have today, I like to call prototyping, where you also in iterations together with the customer, find the best way to produce, which is not just the conventional production, but also additive manufacturing. So this is a framework, and sometimes you choose for 3D printing, but when do you choose for 3D printing? And I found at least 3 very distinguishers, values of 3D printing. And one is that it is flexible. So each print can be different at no additional cost. Another one is, of course, it's fast. It's like a matter of hours instead of months of regular production with injection molding and so on. But a very exciting third thing is that it can be decentral. You're not stuck to a rigid factory at some place. You can produce decentral at various locations at the place where you actually need it, for instance. So what I did is I map these 3 unique values of 3D printing to these various stages of prototyping I explained. And then I will share a few examples with you, but also my view on where it could be going. So in prototyping you find many examples that are about being flexible. You can make anything tangible and to provoke a discussion. This is an example that I like, Centriphone. So on the left you see, this is a prototyped example of an iPhone sleeve, an aerodynamic iPhone sleeve that you can circle around you attached to a string, and then on the right you see if you make a slow-mo movie you can get really stunning results. So this could have been one of the examples when I worked with the Canon Design Center. They did a lot of these kind of experiments to gain momentum and try to get these kind of things in the camera business as part of the regular development program. So, but what if we focus our prototyping support on making use of all the 3 unique values of 3D printing? And then I think we can be even more stronger by also making use of this decentral aspect. So I was talking about the Canon Design Center. In order to get the stakeholders to make strategic decisions, you often see that they are spread over multiple locations all over the world. So at Canon, for instance, you had R&D centers at several places, but also you have sales regions all over the world. And they are also creative, not just designers. They also have input and ideas, and they also have an opinion. So how to get them all together? So I thought, why not print these prototypes simultaneously at several locations, let the stakeholders experiment to play with it, make adjustments and changes, and get them back centrally to the design center. So these kind of things you could think of. Today they are already possible by the community software, but you could really think of facilitating this as a service. So now back to prototyping. Many of the examples in prototyping are also about having fast something to support the design cycles. And this is an exciting example from ODocs. They found out that approximately 250 million people all over the world are developing treatable blindness. And that's treatable with expensive equipment by eye doctors. But 90% of this group is living in developing countries that don't have money for this kind of equipment. And then this eye doctor from ODocs, he found out an equivalent which is at a fraction of the cost by printing several add-ons to a regular iPhone and with some standard lenses. And the exciting thing about this prototype, because if in the end millions of people are using this, then conventional production methodologies are probably more likely. But in this stage, it is being experimented with in a community of several doctors all over the world. And they all give their input and they do tweaking and tuning on it. So this is really decentralized prototyping. So what if we focus also on this using all these aspects, the decentral, flexible, fast, also in service design and product service systems. I found more and more examples that give me a clear idea that tangible artifacts, tangible parts, are getting more and more important as part of a total service. And I think what was also mentioned yesterday by Kees van Dok from TomTom, it is something that can help making a service tangible by having something that can also contribute to a corporate identity, which gives the brand a face and can increase brand loyalty. But also from customer perspective, it's often much easier to have something to close the loop, which is tangible, than just always pulling out your iPhone. And one of the examples that I found was from a service provider in facility management, Planon in the Netherlands. And they use these smile emoticon buttons in the elevators and at the reception in the restrooms. They are prototyping this in order to get customer feedback to continuously improve their service level. And on the left you see another example, a more product service system, and what it does, it automatically controls your home temperature, your airco, and as part of this system, which actually uses tracking your location to make an optimal house temperature, what it needs is some piece of hardware to switch on your air conditioning on and off. But it doesn't do much more than this. And this was a Kickstarter program with a lot of backers because people saw value in it. But what the actual physical object does is nothing more than switching on the airco on and off. So all the intelligence and the added value is in the cloud. And that's often the case with your services, is my feeling. But you need something tangible to close the loop. And now this specific case, it was postponed to release many times because of the long industrialization and industrial design and printed circuit board development. Well, I think if you see the earlier case of ODocs, they were testing in the field worldwide. I think this is what they could have been done if prototyping was easy of these kind of Internet of Things modules. So my vision is that these kind of simple modules, which is just often a button that needs to be connected to the internet, to your service, or just one LED or something, that should be supported in 3D printing in the future. So today we can create the covers, but we also should be able to embed very simple, basic electrical components to disclose your service. And so that could be something that I will work on as a future Ultimaker service. But then to production. There are also examples that we are already active in this area. And one example is from Siemens. So they use it in prototyping to make, well, of course, to make prototypes of certain parts. But when it is a finalized and released part, then a production, then a mold is made around the 3D printed prototype, and that's used to cast the actual iron part in it. So it's actually part of the production process, at least the beginning, so that's interesting. But I'm now more curious on where will be the big movement, and I think again, if it focuses on all these 3 value areas. And I foresee that there's quite interesting parts to use additive manufacturing in the areas where stock and transport is expensive and where just-in-time is crucial. And one example I can mention here is, for instance, an oil platform. And one could think of a total service where the repairman is fully supported with a system who knows when parts are probably going to break down or have broken down, and that have a library of these that can be printed or cannot be printed, know that, and also steer all the printers there. So you have like a factory on board. So these are likely examples, and also part of it is already happening, but I'm also thinking out loud, where are we going and what will be happening? But the actual interesting thing to know more about this is you. Because I think what you will be doing, what you all are doing with 3D printer, keeps surprising me, and we keep finding new things. So hereby I invite you all, look me up at LinkedIn and tell me what you do with 3D printing, and share your thoughts with me, and I will dive into this to bring 3D printing really towards solutions. Thank you.